On the bench today we have a mini Tube Screamer TS9 schematic, and we're going to convert this into a TS10. So first of all, let's take a look at the schematics. Let's start on the Electro Smash website, Tube Screamer analysis. Scroll down to the circuit. We're going to zoom in on this resistor here called RA. That is the only difference between a TS9 and a TS10. So there is no resistor in a TS9, and there's a 220 ohm. So we're going to probably remove this cap and replace it with a cap resistor combination. Probably put a switch in so we can compare TS9 to TS10 and see if there's actually any difference. And then I also see some mods from TS9 to TS10, and a lot of these capacitors in the signal path get replaced from electrolytics to non-polarized. So I'm gonna, and they tighten up the tolerances, so something from a 15 to 10% tolerance to 5% tolerances. So I'm gonna measure each one of these in the signal path. This guy, probably this guy because that's a filter, this guy, and these here at the end, and check that they're within a 5% tolerance so that we don't have to change them. Let's get the Tube Screamer under the microscope now and check the signal path, because I'm not sure that all these values apply, because this is an 808 TS9 TS10 schematic, and I don't know how that compares to our TS9 mini. So first of all, we need to check the signal path and verify that D1, D2 are the right diodes, C2 is the right cap, RA, sorry, we don't have an RA in there, we're going to add it, but R4, C3, etc. are all correctly labelled in the mini Tube Screamer. So let's do that now. I have it now under the microscope. Let's have a look around and see what's what in this circuit and try and validate that we have a good schematic. This is the input jack here. And then there's TR2, but according to the schematic, TR1 is the buffer transistor, and I think TR2 might be the FET switch. Here's the op amp. It's correctly labeled as a Japanese radio company 4558, so that's all good. D1, D2 are correct. This is a new high gain mod that I added in a previous video, see link above. And then inspecting all the capacitors, I'm only seeing one electrolytic capacitor, and that's this big guy here, and that looks like in its position, close to the power supply, and this reverse polarity diode at the top here could be for the power supply. Most of the capacitors are surface mount tantalums, and they're polarized. There's a couple of ceramic non-polarized, which is quite interesting. I'm going to measure them and see how close they are to the actual values and see if they're within plus or minus 5%. I've been around the circuit now and tested everything. The caps all look good within tolerance. I've also traced it through with the scope and a signal generator. Everything appears to be labelled as per the TS9 schematic in the signal path, so that looks good. One correction though, that the Q1 and Q2, or TR1 and TR2. TR1 is the input buffer and TR2 output buffer. Previously I said TR2 was part of the switching circuit, the FET switching circuit, but they're both the in and out buffers. So that's all good. The whole circuit looks like it works fine. All the components are labelled as expected. And now what we're going to do is remove C2 here, and that's labelled 105, which means 1 microfarad, and we're going to replace that with 2 wires and put a switch in, so when the switch is in one position it'll remain a 1 microfarad, and when the switch is in another position it'll be a 1 microfarad and a 220 ohm resistor, and we'll have it on a switch so we can toggle the switch and then do some measurements and see if there's a real difference between the TS9 schematic and the TS10 schematic. So let's go ahead and do that now. I've removed the 1 microfarad cap now and retinned it. I'm going to add some fine wire now and probably some hot glue on top so it's mechanically sound, so I don't snap the wire, because we're going to put a switch on it which is going to have some weight, and we're going to be switching the switch on and off, and there's going to be components in the path as well, so we want to make sure it's mechanically sound for the tests that we're going to do to verify that this 220 ohm resistor really changes the tone of the TS9. We've got the circuit, or the pedal, hooked up now to the scope. We're generating a 1 kHz sine wave, 300 millivolts, equivalent to, say, a single coil, and the 1 kHz sine wave is displayed on the screen. So if I switch the pedal off, that is the through, so that's bypass. It's not true bypass, but you know what I mean. And that's with the gain about halfway, treble about halfway, and volume around about full. And so if I engage the switch now and add in the 220 ohm resistor, there's a very slight change. I don't know if you can even see it on the camera. So what I'll do on the scope is probably increase the amplitude and then roll it down so we just see the top, if that's possible. Is that possible? Yeah. And then switch the switch. So can you see the small amplitude change? So that's without the 220. And then there's a slightly lower signal with the 220. So it's very marginal in the change of amplitude. Let's try a frequency response test. This is the frequency response curve without the 220 ohm resistor, and then this is the overlay with the 220 ohm resistor. So you can see the frequency response, it's exactly the same with this condition. So we've got the gain set to about halfway, treble set to about halfway, and volume set to max. Interesting. Clean sound. Let's engage the pedal. So that is the stock position, so that's a TS9. So if we now move the switch over, now we're in the TS10 or the 220 ohm position. Back to TS9. I may imagine there's a difference, but I don't think there is. So let's conclude. I think what I'd like to say is quite a few things in this conclusion, because it's a conclusion that's almost non-conclusive, because there's a TS9 versus a TS10 legend to maintain as well. So let's talk about the capacitors. Electrolytics and bipolar electrolytics have what's called equivalent series resistance, and that's quite high compared to the tantalums. So there could be 1 or 2 more ohms added in the TS10 circuit, which will affect the overall gain and warmness. The tolerances of the capacitors may be different. So the TS10, on a lot of the mods I see, they say put 5% tolerance capacitors in, and I think these are more like 10. So we could tighten up the tone, so there could be a difference there. Does the 220 ohm resistor make any difference? It makes a tiny marginal difference in amplitude. So suppose if you're playing in a massive rig, you might be able to hear that difference. Less spiky, just a couple of millivolts driving your amp from non-clipping to clipping. I don't know. But it's been an interesting mod. I think there's more to be done with this. I'm definitely going to get a TS10 now, so I can do a side-by-side and really work out analytically what the differences are. But that's it for this week. Please like and subscribe, and I'll see you in the next video.